Good afternoon and welcome to another video for the Metropolitan State University video walkthrough of the Elementary Acupuncture Study Guide. In this video we're going to be talking about and solving multivariable equations. And in the previous video, or the previous two videos, we explained and we solved single variable equations, linear equations with one variable in them. And because of that, my answer, if say my variable in that equation was x, my answer looked like this. X equals, and then we had some number. And whether that was a whole number, or a fraction, or positive or negative, but it was a number. But because in this section we have multivariables, our answer is going to look like if I say, there's x's and y's and z's, and I say solve for x, then my answer is going to look something like this. X equals, and then it's going to be a mix of numbers, and I'm just going to make this up. It might say, 3y plus, 4z minus 2. I don't know. But it's important to note that our answer will not just be some number. And this is because, and I mentioned this in the last video, but if I have, this is a pretty simple example. If I have, say, 5x, plus 2, I can't do anything with that because this has an x here, and this expression over here, this number doesn't. I can't add them together. And if I have something like, let's say, p plus q plus, 3r, that is what it is. I can't add those together. And because I can't, our answer, in these next couple of practice problems, they might not seem as simplified as we'd like to make them. But I really can't do anything, or I can only do so much with these. And the last thing that I'll say is that, so because we can't add them, we're just going to treat them like they're numbers, because if we're solving for, say, x, and we don't care about the y's and the z's, we're going to treat those like numbers that we can't add together. But in the same sense, and the same process that we used in the previous video, we're still going to move them to one side, and we're going to isolate or solve for that one variable that the problem tells us that we're looking for. So it may not be just one number, but it will. Our answer should look like, if it says solve for x, it should look like x alone on the one side, and then whatever else we get on the other side, and we'll see a variety of things. But that's it for the explanation as far as before we get into the problems. And so within this one video, I'm just going to jump right into the problems. And there's only 6 problems, so I'm going to do all 6. I do encourage you, since I'm doing all the problems, try and, maybe after we do the first one, try and pause the video and work on the next one before we do it yourself. Check the answer in the back. And whether you get it or not, we can follow through step by step after that. Unpause the video and watch what I do. But because I'm going to do them all, please try them on your own. All right. So without further ado, I'm going to scroll down and just start off right down here, and we're going to start with problem number 1, and we're on page number 16 of the Elementary Acupuncture Study Guide. And on page number 16, the first practice problem says S equals P, in parentheses it says 1 plus R times T, and then it says solve for R. Alright, so what do we do? Well, there's a couple different things that we can do, or 2 different ways we can approach this. And sometimes there are 2 ways and sometimes there aren't, but depending on which way we proceed, we're going to get 1 of 2 different answers. And really they're the same answer, but they're going to look a little different, and both the answers are going to be in the back. Because of that, I don't think you're going to see something like this on the test. They're not going to have 2 answers, I guess, on the test that are correct. But really they're the same answer, and one looks a little bit nicer, I guess, than the other one. So if they do have something like this, it'll probably be the more simplified answer, and so that's what I'm I'm going to work to get the more simplified answer. But if you do it the other way, check the back and see if one of the answers matches. Because even if this answer's on a test and it might be in a different context, or it might have a different solution. If you can work it out to get one of the answers in the back, then at least you're on the right track as far as working the problems out. So the first thing that I'm going to do is I need to solve for r, right? But what I'm going to do is I'm going to simplify it, right? And a lot of times, there's with multivariable problems, you can't really simplify too much. But in this sense, we can, because we can distribute this p into the parentheses there. And so what it looks like now is I have s equals, well, p times 1 is just p, and then plus, and again, we're treating all these like numbers that we can't actually multiply together, right? That we can't actually add together. And so what p times rt is we're just going to put it as p times r times t, and it's that simple. If it was a 5 and a 2, and we don't know the variables, we don't know what they are, but we can still say, well, it's just, we're going to represent it as p dot r dot t, p times r times t. And so now we can work from here, and pretending these are all numbers, we still want to solve for the r, right? And again, just like the last video, the first thing I want to do is get rid of any addition or subtraction that does not involve r. And so in that case, I'm talking about this p right here. And so I'm going to subtract p, because p minus p is 0. So that cancels that out. But what I do to one side, I have to do the other side. So I'm going to say minus p. And again, since I can't actually add or subtract or multiply, them actually together, what it ends up looking like on the left-hand side is just s minus p, just as simple as that. We're just going to keep it in letters. Equals, and then I got rid of that p, so now it just equals p times r times t. And just like in the last video, just like before, we want to get rid of the p and the t, right? We just want r. And so if p was like a 5, right, I would divide by 5. And if t was a 2, I would divide by 2. And so instead of that, I'm just going to divide by p times t. Because now when I divide by whatever p is, p divided by p is still 1. So those cancel out, and that's a 1 there and a 1 there. And the t's cancel out, and that's a 1 there and 1 there. T could be, 10,000. But if it's 10,000, it's 10,000 on the top and bottom now. So they still, 10,000 divided by 10,000 is still 1. But again, whatever I do to one side, I have to do the other side. So I'm going to divide by p times t over here. And then so my new equation looks like this. I have r on one side, and I'll write it out like I have it. I like having my variable, the one that I'm solving for on the left, but I'll write it out the way we're solving for it. I have s minus p divided by p times t is equal to, and now we just have r by itself. And so that's the answer. And again, I like having my variable that I'm looking for on the left. So I'm going to write it as r equals s minus p over p times t. And either way, these are both correct. I mean, just flip-flopping what side the variable's on, but where they're all variables, but the one that we're solving for. And really in the back, I mean, all that's going to be in the back or on the answer key, number A, I guess you'd say, is just the section that I boxed there. So it doesn't really look any different. But if they do have the whole equation, then they will also have the one that you're looking for on the left-hand side. So the answer, if they have the whole equation, is going to look something like this. But again, as long as you recognize that they're both the same, your answer is absolutely correct. So, all right, let's move on to number 2. Number 2 says, put a little squiggly. Number 2 says a equals pi, and this is the Greek symbol for pi, r, and r is squared. Pi r squared. And then it says solve for r. And, if this looks familiar, this is actually the area, which we use a to describe area, the area of a circle, where pi is a constant, and I'm sure you've heard, pi before, 3.14, and it goes on forever. And then r is the radius. So they're giving us the area of the circle, and they want us to find the radius, except we're just talking about variables right now. We don't know the numbers for any of them yet, but we can still solve symbolically for the radius. And the first thing I want to do, as I said in the previous video, and I just actually said in the previous problem, we want to work backwards from the order of operations, right? And so we're doing two things here in this problem. We're multiplying r by pi, and we're also squaring r. And so if we remember our order of operations, PEMDAS, the exponent, right, is actually above the multiplication. And since we're working backwards, we want to get rid of this multiplication part first, this operation right here. And so how do I get rid of that? Well, again, just like in the previous problem, in the previous video we talked about, we want to divide by pi. Pi is a never-ending number, but pi divided by pi is going to be exactly 1 because they're both exactly the same number. And so we get a 1 there. But then I have to divide this side by pi. And so now my equation looks like the area A divided by pi, the constant, is equal to r, the radius, squared. So how do I get rid of something squared? Well, again, I said this in previous videos, I think when we were talking about exponents. If I have something like x squared equals 25, then intuitively you might be able to say, well, I can see that that's 5. But how do we do that? So the first thing, well, the only thing, I guess. So I'm going to take the square root of x squared, right? And I do that because now if I rewrite this, you know, like we discussed in the exponents or the radicals video, I can rewrite this as x to the 2 over 2, which is just x to the 1, which is just x. And then whatever I do on one side, I do the same thing to the other side. So I'm going to take the square root of the other side, and the square root of 25 is 5, or it's actually plus or minus 5. But that's how we do it, right? Like we're taking the square root because that's how we take the radical, and there's an unwritten 2 there, but we take the radical that matches that exponent. And if something was already the square root of the cube root of something, to get rid of that, if it was like the cube root of x equals, whatever, then we would raise it to that exponent. So if I have, for instance, again, the cube root of x equals, let's say, 2, then to get rid of that cube root, I'd want to raise this side to the third power, because now again these two, this radical and this power here match, and it would be 3 over 3 or x to the 1 or just x, and then whatever I do to one side I'd have to do the other side, and we went over this in the exponents video. But now I'd say, okay, well, x is equal to 8, which makes sense because the cube root of 8 is 2, right? And so when we talk about this over here in terms of just variables, we want to do the same thing. Even though it's an r instead of an x, to get rid of this square, I need to take this square root of this side, because the square root of r squared is simply r. So I have an r, and then, well, whatever I do to one side, I have to do the other side, so I'm going to take the square root of it. And so r is equal to the square root of a, the area, over pi. But we're not quite done yet, right? Because if we look over here, I said the square root of 25 is 5, but I actually said it was plus or minus 5. But you don't really see that much in this book. We see it a little bit later on. But in the back, for this particular problem, because we're taking the square root, the answer is actually, because whenever we take the square root of something, it really is plus or minus whatever that is. So the answer is actually plus or minus the square root of a over divided by pi is equal to r. And so the answer is actually going to look like this, plus or minus that, because when we take the square root of something, if I took the square root of 25, it's actually plus or minus, because negative 5 times negative 5 is also equal to 25. And that's all based on, what radicals are, what squares are, and we've already done different videos for that. So if it confuses you at all, please go watch those videos if you haven't yet, and if it still confuses you, you can come on into the tutoring center. But hopefully that makes sense to everybody. At least how we got the square root, this answer up here, the square root of a over pi. But again, because it's a square root, it should be plus or minus. All right, moving on to the next problem. Number 3. And number 3 says 4a, 4 times a plus 3b, 3 times b, is equal to 30. And it wants us to solve for b. Solve for b. This is actually a really pretty straightforward problem. If we treat all the other variables, or the one other variable in this problem, as really just like a number that we can't add to anything else, but if we treat it like that, then the only thing I really need to do right off the bat is well, I want to get rid of this 4a first, right? I'm adding that. I have a 3 times b over here, and so reversing the order of operations, I want to get rid of the 4a first, and so I'm going to subtract 4a, and then 4a minus 4a is 0, and so I want to subtract 4a from the other side. And again, I can't 30 minus 4a, I can't really do anything with that. So our equation simply becomes 3 times b equals 30 minus 4a. And again, this is 3 times b, and we want to get rid of the 3, so b is all alone. So we're going to divide by 3. 3 over 3 is simply 1. And so our equation looks like this. It looks like, well, I have to divide both sides. The other side, exactly what I did to the other side. So I have to divide that by 3, and our equation looks like b equals 30 minus 4a divided by 3. And that's the answer in the back. But if we wanted to go a little bit further, I could say, well, just like we combine fractions with the common denominator, we kind of split them up the same way. So I could say, well, that's the same thing as 30 over 3 minus 4a over 3. And if you look at this, you can see how we would normally go from there to there. And the reason I might split it up like this is because I know what 30 divided by 3 is. That's a whole number, so I might like that. So from here, my answer would look like 30 divided by 3 is simply 10 minus, and then I might write it like this. I might write 4/3 a, or I could write it like I wrote it up here as 4a over 3. It doesn't matter, they're both the same. But you want to kind of, like I said, this is the answer in the back. But you want to get used to maybe, I'm not sure if you're going to have to do this on this test, but splitting it up, if it looks like it could be split up, or even if it can't, even if you get like some fraction like 5 over 2 for this number right here, because once we get into, it's either the next section or the section after, but when we get into lines and graphing and talking about y equals mx plus b, which is the point slope equation, which you'll get very familiar with. You want to really be comfortable doing this kind of stuff. So either one of these answers is correct. I would say that this answer right here is a little bit more simplified, but the answer in the back is actually this one up here. So, and you would, if you simplify it maybe too far and you get to my bottom answer over here, and you don't see that maybe as one of the options, but you see this one up here as one of the options, well, then you should say, because you're going to have scratch paper and stuff, oh, I went through that answer on the way to my other answer, so I guess that's okay. I'll just circle that answer. It's the same thing, just different ways of expressing it. All right, let's move on to number 4. All right, number 4 says 3 times g times k, and so we're having another one of these where we have 2 variables in one setting right here, just 3 times g times k plus 1/2 g is equal to y. And then it says solve for g. And if this was just if it's if g was our only variable here, and k was an actual number and y was an actual number, well, even just k being an actual number, then at least we could combine these two. We could combine 3gk and 1/2 g. It might be like 5g plus 1/2 g or something. We can combine them. But because there's a k over here, another variable, we can't combine these two, and yet we need to solve for g. And the way we do that, and we'll get into this a bit more in one of the future sections, it's going to be a bit a lot more in depth on this, but we're gonna factor out a g because we're solving for g, and factoring is really it's undoing distribution. And so to factor out a g, in this case, I just, and again we'll get further into how to factor different things out of what. But if I just wanted to factor out a g here, I can simply say to myself, well, there's a g here and there's a g here, so there's a g in both of those. And so I'm going to factor out a g. So I'm going to rewrite it to look like this: g equals, and then if I pull a g, I'm sorry, not g equals, but I'm going to pull a g out, and so I have g times. And if I pull a g out of this first expression here, excuse all my squiggly marks, but if I pull a g out of that first expression, what I have left is, what you're essentially doing is you're dividing by, I say I'm pulling out a g, but mathematically what you're doing is you're dividing by that g. And so if I divide by that g in this expression right here, then the g goes away because g divided by g is just 1. But I pull the g out, I divide by the g, and it goes away. So what I have left is 3k. And it really makes sense when we look about distributing, before we even go any further. If I distribute this g back in, I have I have a g times 3k, which is 3gk, which is what the expression we had above. So it makes sense. Okay, that's what I have left. Plus, right? And if I pull a g out of that 1/2 g, what I have left is, well, if I divide by g to get rid of that g, I have 1/2 left. And again, that makes sense because if I distribute that g to the 1/2, I have 1/2 g, which is what my term up here was. So that's great. Equals y. And one thing I'll note over here, I'll say that if you have something like 5x squared, and again we'll get into more of this later on in one of the later videos, but 5x squared plus x, and I wanted to pull out an x, what I would have would be x times 5x, and that makes sense because if I divide by x, I have an x left, but in particular if I multiply back through, I have x times 5x, which is 5x squared, plus, and then a lot of people think, well, if all you have is an x and you pull it out, you factor it out, then I won't have anything. I'll have 0. But you don't. You have a 1 left, right? If I had a 0 here, then when I distribute this x to the 0, right? X times 0 is 0, so it'd be 5x squared plus 0. But if I have a 1 left, if I divide it by x right here, x divided by x is 1. And if I have a 1 left, then when I distribute my x back, I get x, and so I'll get 5x squared plus x. So it's important to note that if you're pulling out everything, right? If you're factoring out your whole term, whether it's just an x or maybe it's even like a 3x squared, because of all the different stuff that you might have, plus something, if you pull out a whole 3x squared, you don't have a 0, you have a 1 left. So if you pull out your whole term, you have 1 left. I think I've repeated myself enough for that. But now I can solve for g at this point, right? Because I factored out a g. Now nothing in here, there's no g's left in here, and there's no g's over on my other side. So my only g is right here. And I need to get it alone. So what do I do? Well, this might seem kind of odd because we have variables and stuff in here, but imagine if this in here were numbers, and instead of like if k was 1, this would just be 3 plus a half, or even let's just pretend instead of a half it's just 1, right? So 3 plus 1 would be 4, and we do that math and we say, okay, now we have 4g. We would divide by 4, right? Well, we can't add this stuff together because we have a 3 times k plus 1/2. We can't add that together. We can't simplify it all, right? And yet I still need to get rid of it. So what I'm going to do is I'm going to divide by that exact whatever's in there. 3k plus 1/2. And it might seem like we're taking a big step in just this one thing, but really 3k plus 1/2, or any expression divided by itself, is still going to continue to be 1. So that's a 1 and that's a 1. And now we just have g. And now I just got to remember I got to divide by that whole thing. I got to do the exact same thing that I did over here. So I'm going to divide by 3k plus 1/2. And this might not look pretty, but really g, when we solve for g, it's equal to y divided by 3k plus 1/2. And if we look in the back, I mean, this is the answer. This is what they want. So even though it might seem like, you know, we're kind of cheating by just dividing by that whole thing, that's all we can do. And so g is equal to y divided by 3k plus 1/2. And you could leave the parentheses in there, or you don't have to, but at least in doing the problem, it helps out a lot, kind of to see what you're doing. And you do need them there after you factor out. All right, number 5. Number 5 says d equals, we have a lot of variables in this one, g plus j plus f plus k, all divided by 60. And I need to solve for, what am I solving for here? I'm solving for j. It'd be nice if we were solving for d, but then it wouldn't really be a problem. We're solving for j. And remember, again, through the previous 2 videos, one of my tips was, you know, get rid of any fractions first, right? And so the first thing I'm going to do when I'm solving for j, this is my variable that I want is up here, you know, and there's, again, it's a fraction, so I'm going to put parentheses around the numerator. I'm going to get rid of my fraction, and it's not a very complicated fraction. You know, if these were all numbers and we, you know, there was just an x in there, this would be a very simple problem for us now after the last section that we did. And we're just going to treat those other unknown variables just like numbers. And so the first thing I'm going to do is I'm just going to multiply by 60. Why? Because, well, now, I mean, it's simple. I just got rid of my fractions just like that. 60 divided by 60 is 1. Whatever I do to one side, I have to do the other side, so I'm going to divide by 60. And now my equation looks like d divided by 60 is equal to g plus j plus f plus k. And again, if we're treating these other variables as simply numbers that we can't really add together, then what do I'm going to scoot this up a little bit. Then how do I solve for j? Well, I'm just going to start subtracting all this, right? If g was, say, like a 5, I would just say, well, minus 5, right? So I'm going to say minus g. And I'm actually going to do this all in one step because it's very simple math. I'm just going to subtract g. I also need to subtract f if f was like 10, and if k was, you know, 20, I would say minus 20, so minus k. And then g minus g is 0, f minus f is 0, k minus k is 0. And so now all I'm left with is j. And then, but I just got to remember that everything I just did, I have to do this side. So I'm going to subtract g, I'm going to subtract f, and I'm going to subtract k. And so I have j either on the right or the left. I'm going to put it on the right just to kind of keep track of where we are, but I usually put it on the left. And then over here I have, well, let's see, I have d divided by 60, and then I have minus g minus f minus k. And, you know, as unsimplified as that really looks, I mean, that's the best we can do without knowing what d or g or f or k are. We can't do anything else. Like I said, we can't add those numbers together. You know, if we treat them like numbers, but we can't do anything with them, that's it. And so this is our answer right here. That's it. All right, moving on to number 6. If there are any questions about that, please come into the tutoring center. Number 6. I have y divided by h plus, you know, outside of the fraction, plus 6 equals z, which, you know, doesn't look that bad, but it wants me to solve for h. Solve for h. And h is in the denominator. Well, let's get rid of our fraction first, right? Well, not first, but before I worry about solving for h, I want to make sure I don't have any fractions. Now I could, you know, I could say, well, that's really just 6 over 1. I turn that into a fraction, and I could combine it, you know, into one fraction by adding the fractions together. But instead, since you know, this 6 right here doesn't really have anything to do with my the variable that I want to solve for, I'm just going to subtract 6. I'm going to get rid of that first. And now I have y divided by h is equal to z minus 6. Okay? Now, there are a couple things that you can do here, and usually the easiest is just to say, well, I want to get rid of my fraction, you know? I'm not going to worry about solving for h until I get rid of my fraction. So, I'll put a little parentheses around that. I'm multiplying by h here, because h over h, that's going to cancel that out, and I want to get rid of my fraction before I worry about solving for h. And I put the parentheses around z minus 6 because I have to multiply this whole side by h. I can't just multiply z by h, and I can't just multiply 6 by h. I have to multiply the whole side by h. So I put parentheses around the whole side, whatever that whole side might be. Now, before, you know, if it was just a letter or if it was just a single number, you know, we just multiply by h, and that's all there is, you know. But because there's an expression over here of z minus 6, we need to make sure that whole expression gets multiplied by h, and so we would put parentheses around it just like we would need to distribute it, except I'm not going to yet because I want to solve for h. So just remember to put parentheses around anything like that. When you multiply one side by something, you have to make sure you'll multiply the whole side by that. And so I'm going to rewrite my fraction, or my expression now, my equation. I have y equals, and I still have this in parentheses, z minus 6 times h. And if I were solving for y, you know, that's great, I'm done, right? But I'm not. I'm solving for z. And just like in one of the previous problems, I don't recall, let's take a look up here. Just like problem number 4, right? We had g times, you know, 3k plus 1/2, and we had to divide by that, needed that whole little expression in the parentheses. I'm going to do that again right here. I'm going to divide this whole side by the expression z minus 6. I don't know what z minus 6 is because z is a variable, you know, because z could be any number. But I do know that z minus 6 divided by z minus 6 is always 1, because anything divided by itself is 1. And so now I just have an h. I'm actually going to write it on the left-hand side now. H equals, well, whatever I do to one side, I have to do the other side. So I have to divide this y by all of this z minus 6, whatever that may be. And so h is equal to y divided by, in parentheses or not, z minus 6. You know, as long as you have it all under that same denominator, it's just z minus 6. And if you look in the back, and I'm going to double check myself because I don't want to be wrong. Number 6, h is equal to y divided by z minus 6. And so this is our final answer right here. And you're not going to be doing this too much with a crazy amount of variables. Like, you know, one of the problems, I think we had 5 variables and we were solving for 1. But you do want to get used to this because you are going to be spending a lot of time on y equals in terms of x, right? You're going to have y and x, and you're going to be solving for y a lot as far as graphing goes, and that's what a lot of the next couple sections are about. And so you want to get comfortable solving for y while there's another variable in the equation, such as x. And so hopefully this wasn't too crazy for you. And I know we threw a lot of variables at you, 3, 4, 5 variables in a single problem. Usually you won't be dealing with more than 2 in a problem, but you do want to be comfortable with more than 1 in a given equation. I will see you in the next video.